in the AR session at F8. Oh, my mic is on now. Okay. If you've been with us since this morning, you've learned about our new toolkits in AR Studio, and you've also heard just now from our creators. In this session, though, we'll be looking at it a little differently, and we'll be sharing a behind-the-scenes look of how we scale AR experiences to everyone. So my name is Merlene Dang. I am a product manager for the team. And joining a bit later will be my colleague, Nikita Lutsenko, a software engineer on the team. Let's get started. So any good talk should have an agenda. Let's cover what you're going to get out of this talk first. We're going to tell you a little bit about our vision for the Spark AR platform and how that influenced our decisions on how we built the AR engine, one of the core pieces of AR product infrastructure at Facebook. First, I'll give an overview of how we started the Spark AR platform and the augmented world that we're building toward. Next, we'll talk about the state of the union today. What do our users look like? What kind of devices are they on? And what are some of the delivery challenges that we have? Third, once you've learned about the scaling challenges we have today, I'll hand it over to Nikita for the last two parts of the talk, where he'll talk shop about how we optimize for AR reach while minimizing work for you, the creator. And then finally, every good talk should talk a little bit about how you apply these learnings. So Nikita will cover how you can take advantage of these lessons and apply them as you build AR effects in AR Studio. All right, so AR is one of the most exciting emerging technologies out here today. But why does Facebook care about AR? We've been building toward an augmented world. Actually, Mark spoke a little bit about this earlier. A world that is populated with smart virtual objects that you can see through increasingly powerful devices, that some of which are here today on smartphones, but will also be arriving in the near future. These virtual objects can do things like entertain, such as the face filters that you use today, or the digital chessboard that you see in Mark's presentation up there. But they can also be objects that will assist you, inform you, or connect you to your community. This is an incredibly powerful vision. And so how do we even get started on something as ambitious as this? Mark started this vision back in 2017 when we began investing in the mobile camera as the first augmented reality platform. I've been amazed to see how and what has happened over the last 2 years, where phones could barely run AR 2 years ago to where we are today, with an upcoming open developer platform on Instagram and many, many new emerging applications, some of which I'll talk about later today. It already feels like an eternity since 2017, but by now you've heard over 1 billion people have used AR on our platform. The reality is these 1 billion people use AR in all different parts of the world, and they're all different from each other. Where we have a responsibility to build an AR system that optimizes for these differences so we can actually deliver very compatible AR experiences to everyone. So this actually puts us in a very unique technical challenge. How do you balance creating AR that can scale to 1 billion people with a long-term AR vision that we have? Well, we should actually be deliberate about the recipes that go into an augmented world, what kind of capabilities we like, what kind of devices we need to support, and then what we're going to do in the rest of this talk is discuss how do we solve these problems in context of our community today, which is quite large. So the beginnings of an augmented world have already reached hundreds of millions of people every month across Facebook, Messenger, Instagram, and Portal. These are all incredibly different product experiences and surfaces, and they represent completely different communities. To get to a world that everyone can experience, we've had to intentionally invest in the following: expansive platform support to deliver AR where people are. We have to continue to innovate and deliver mobile-friendly AR capabilities. Number 3, we have to continue adding new utilities to AR that go beyond self-expression, the face mask that we love so much. Well, we should be able to do a lot more with that. And then finally, if we're building toward this really ambitious augmented world where the world is literally populated with these virtual objects, we need to begin pushing the technical boundaries of the kinds of AR experiences you have. So 2 years ago, we started really basic. We started off with desktops so that you could experience AR experiences in your news feed, but over time, we've realized that there are many more devices and form factors that can leverage and embed AR in the experience, such as tablets. One of my favorite experiences is actually playing and talking to friends, talking to children on Messenger Kids. So my niece and I talk a lot through the tablets that Messenger Kids has. Of course, we have mobile, which presents really unique technical challenges that we'll cover in a second. And then, of course, over time, we're like, there are more devices that are coming up on the horizon, and that includes products like Portal, which you've heard about a lot earlier today. Now that you have devices that can experience and deliver AR so that it's user-friendly, you need to make sure that the world that you are augmenting means that you have to understand the people, the places, and the things that are in it. And you use the latest and greatest computer vision algorithms to get this done. We start with people, which is the most popular subject on the other side of someone's camera today. Everyone knows what the selfie is. Actually, 3 or 4 years ago, the selfie wasn't that big of a deal, and now that's everything that people capture. And AR has been an incredible catalyst for this type of self-expression, where knowing where your face is in the camera viewfinder allows you to create these compelling masks. However, we're not stopping there. We're starting to add on more AR capabilities that understand people, from things like faces to person segmentation, and then most recently, this new hair segmentation feature that we're working on. This is all AR. This looks incredibly real. I wish my hair looked that good. Now, people is a really important part of the mobile experience today, but the world behind your camera has many other interesting things in it. And the camera users today will start capturing other interesting parts of the world. Our AR capabilities have already done a great deal of work to understand what is in the scene through things like the region tracker, or the point tracker as it's known in studio, to the 2D target tracker that you see populating all of the halls at F8 through our scavenger hunt. Next, now that you know that you can track different regions and different parts of a space, what is it? Can you start recognizing what are the objects in a scene? And that's something that we call semantic scene understanding. This is some of our latest and greatest in cutting-edge AI technology. But now that once you can tie all of this together, you can actually place really interesting and compelling things such as this 3D text into the world so that it's context aware, it knows where the plane is, and you can experience and interact with it. Now, in this video, you'll notice that this is 3D text come to life, but you sort of just walk straight through it. It still feels kind of artificial, right? One of the next things that we're starting to work on, and it's one of the most interesting and technical challenges out there, is how do you actually blend virtual objects seamlessly into the real world? In this example, the phone camera has become an incredibly powerful tool with abilities to run next-generation AI capabilities on device. But being able to hide this virtual object, this coffee cup, so that it's in context of the scene is actually one of the most exciting sneak peeks that I have to offer you today. This is something that's called occlusion. And being able to run occlusion on mobile is an active research area for you to make AR more and more believable. Now, we talked a little bit about capabilities. Let's talk about what you can do with them. We have clear product market fit where people use AR to express themselves. And this is essential for sharing creative moments with friends. But with these new capabilities, we're starting to unlock new use cases that are high utility, creative, and actually very fun. We're starting to see examples where when AR gets good enough, it feels real enough that you can visualize a virtual object on you or at home. If you shop like me, you do most of your shopping online, and it's a constant challenge to figure out if that particular item that you're looking at is going to go with your lifestyle. This is actually a very common source of fatigue. So AR can help, and these are some real examples and campaigns that we ran last year. In this example, Michael Kors is leveraging the face tracker that we just talked about so that consumers can try on a digital version of their sunglasses right there in the flow, and you can switch colors. Next, here's a great example of the world tracker at work, where Pottery Barn can exploit the plane tracking system we have to let you try furniture to scale in the comfort of your own phone. Finally, You can combine these capabilities with real-world CTAs, so just as like Nix did with lipstick to let you go from tryout to purchase in one clean flow. This feels really simple, and it's meant to be simple. This is something that is phenomenal and can scale to many mobile devices. By the way, I want to do a little plug. If you're interested in learning more about building for shopping AR, we'll be hosting a session on this later in day 2. So go check it out. So now that we've covered the innovative AR capabilities that are coming to market, let's talk about the mediums of how people use AR. We started off with camera, but we're starting to use more devices and form factors so that we can build out immersive experiences where AR is front and center. AR, over the last year or so, has gone increasingly more embedded in different ways to communicate. There are face masks, but now you can actually use and apply AR for things like group calls with your family on Messenger or when you're going live with your friends. But the best and latest example of how we see immersive AR at work is our recent product launch with Portal's AR Storytime. This is one of my favorite features. Being able to call my grandma and my mom so that we can actually chat with my niece about, like, what is a really great story. This is an example of this where we're extremely proud of the experience because it starts pushing our technical boundaries of AR technology today. But it also delivers a creative and truly immersive experience where people use AR to feel closer together. Now, why can we do this on Portal? Why can't we do this on the phone? This is actually a really important challenge, and as a platform, you need to be able to balance both. Portal has fewer hardware constraints than on mobile, which means that we get to deliver social AR experiences that can be complex. It can support business logic that can actually enter into different chapters and stories. It can support different characters. And you've seen in some of our releases today that we're starting to create these more complex authoring concepts that will make immersive AR experiences easier over time. Now, this presents a really interesting challenge to the AR engine, where on the one hand, you had those 1 billion people on mobile, and now you're starting to see this new emerging stuff with devices, where you can take advantage of Portal's hardware and connectivity environment at home to deliver something that is more complex and more diverse. Now that we've talked about the different pieces of this augmented world that can support devices and many users and all these different capabilities, let's tie this together and talk about what it means to bring AR into our community. As you might guess, balancing who we can bring AR to and what kind of capability and experience we can deliver is an incredibly important challenge to bring AR for everyone. And we have to, as a result, build for different devices, contexts, and platforms. We have a mission at Facebook, which is something that in turn informs the decisions we make as a Spark platform. And our mission continues to be to give people the power to build community and bring the world closer together. At Spark, this means that we have to take an expansive look at who is in our community and how do we deliver AR to them as much as possible wherever they are. Let's take a look at how we structure the problem. In the journey to get to 1 billion, we learned very quickly that the AR community is diverse and has a range of needs. People want to experience AR in all different types of the world at different connectivities, and since we're mostly on mobile still, connectivity is one of the biggest factors on how we design our systems. It's not surprising, of course, that a lot of our AR users will come from places where we have the fastest internet, like in the US and Europe. However, when we start looking beyond into our top 10, we also see a huge appetite for AR in 3G connection areas, particularly in places like Brazil and Argentina, as well as in parts of Indonesia. But what is most surprising is that when we analyze the highest growth countries, it was awesome to see that AR is taking roots in places where internet connectivity is still improving rapidly. This includes important markets like India, where we see some of the biggest growth in our users. So as a global platform, this means how do you actually deliver AR to all of these people and make their experiences the same as much as possible? So in the AR Engine team, we have to talk about the fact that we're optimizing across different classes of devices. Many of them are coming in. Many of them will have different types of capabilities. What is our strategy for exploiting the latest and greatest for the newest phones that come out, but still make AR experiences on par of where the majority of our users are. We have to listen to where the market is and see where the users are. And for us at Facebook, scale is incredibly important. So we define techniques that allow creators power their creative message, but we want to offer you, the creator, flexibility in their delivery to as many phones as possible. There are three primary areas that we look at behind the scenes to make sure that we can deliver on this promise. Those three things are the camera, of course, the phone's motion sensors, and its compute. A small but growing portion of our users will have what we call high-end phones. They boast the latest technology, including multiple cameras, giving you access to depth information, and has the highest visual quality. But they also have things like multi-axis motion sensors, some of which will allow you to blend real-world data to unlock 6 degrees of freedom experiences. Those are the ones that feel the realest and also the most dynamic. And of course, they have powerful compute. However, the majority of our users are actually in what we call the mid-range level, where usually there is a single camera, some level of motion understanding, and some limited compute that we can work for. But as you've noticed, even the lowest ends of phones that are out there today, they have none of this stuff, but they can actually still experience AR, as evidenced by the data that we've seen. And that includes things like a single camera and very limited compute. So you can just barely begin to see AR there. But it's extremely important to think about making AR accessible, because the first place where people will experience AR is not going to be through some wearable. It's going to be on your phone. Now that we've outlined the overview of what 1 billion people using AR looks like, I'll hand it over to Nikita, who will cover how we optimize and scale the AR engine to our audience and what you, the creator, can do to apply these learnings in practice. Thank you.
That is awesome. Thank you, Marlene. Hi, everyone. My name is Nikita. I work on Spark AR Engine. And today I'm going to talk to you about roughly 3 things. First, we're going to dive deep into what is Spark AR Engine, since we actually didn't cover it in detail in public before. Next, we're going to talk about how did we scale Spark AR Engine to the vast set of creators and vast set of communities in the world. And last, learn some of the tips and tricks and some of the tooling that we have there in Studio and Player for you. So let's dive right in. The precise technical description for Spark AR Engine, right? I'm a software engineer, precise technical descriptions. It's a stepwise simulation and rendering system. What it means is that it takes data from a set of inputs, like trackers, as well as audio and video data. It executes and updates the internal simulation. This is where the business logic goes. This is where we put our business logic. This is where you, as creators, can also put your business logic inside. Next, we render corresponding visuals. So every experience that you see is powered by Spark AR Engine. Everything that you see on Portal in AR, everything that you see on mobile is in AR, all of that is rendered together with Spark AR Engine. And well, since this is AR, we always compose with the input image, whether that is coming from camera or that is a pre-shot image or video before. That's quite a lot of technical detail. Let me walk you through a simple visual example. Let's start with a camera. What we want out of the camera by default is a video frame. Video frame is really what contains all those pixels behind the scenes. Now let's go and track the image and see what the color is, or what the skin is of that person, so we can apply a pink color to it. Add a crown on top of person's head using a face tracker, and for the fun of it, let's flip it upside down. So that's the full pipeline of AR. You start with a camera on the left, you end with a preview all the way on the right. And you might have guessed, Spark AR Engine is what powers all of that through the process. It contains key things like JavaScript and reactive runtime. So the runtime is what you put your business logic in. Well, we also have JavaScript engine behind the scenes that we're running and that you can interface with together. To render the visuals, we built a pretty advanced 3D rendering engine. And together with a shader pipeline, that is what is rendering the pink color as well as the crown, as well as, well, we want to flip it upside down, so we're going to do that. And to integrate with every tracker out there, we built a unified service interface. So together with a face tracker and plane tracker and many others, all of that is together unified through a single interface and integrated with platform. And of course, we want to deliver the experiences over the air, so all of it together is tied by an asset delivery pipeline. That's pretty much it. That's Spark AR engine right there. This is what runs every one of those Spark AR effects. This is cross-platform, running in Studio and in Player and on mobile and Portal. Right, that's cool. Awesome. Let's talk about optimizing it. Let's talk about optimizing it for scale, which is really advanced, which is really hard. As we learned from Merlin, not all devices are created equal. This means that all of them has vast set of rendering and performance capabilities, vast range of limitations that come from it, and what we need to do on the engine is actually tailor the engine so we can optimize for all of them, not sacrificing the experience. We also have a vast range of supported capabilities. Say, we want to deliver AR on a phone that doesn't support 6 degrees of freedom tracking. Well, what do we do? Last but not least, we want to ensure the best experience for everyone. No matter whether you use a 2G or 4G connection, no matter whether you're using a low-end phone or a high-end state-of-the-art compute power out there, we want to make sure you experience AR everywhere. Our strategy and our optimizations can be bucketed in 2 large pieces. First one, performance, where we go and optimize for a lot of the runtime logic, a lot of the things that happen at runtime, so everyone experiences is great. And second one is delivery, where we optimize for instant load time so no one sees that loading indicator, no one sees that loading spinner. Our strategy is also quite unique. We want to ensure that the content that you create is the same as you've seen it. We want to ensure that the experience that you create in Studio is absolutely the same, it's not changed. Well, it turns out behind the scenes, there's plenty of room to optimize. There's plenty of things that we can do. What we apply behind the scenes is what we call selective optimization, where we take 3 key things into account. First one, performance prediction, where we try to predict performance of the content as well as the target device. Next one, connection class, which allows us to unblock instant delivery and instant load time. And last but not least, hardware capabilities, where we take advantage of every graphics API out there. Let me walk you through in detail through every one of them. Let's start with performance prediction. So as you build a large system, as you're building a vast system that needs to run on low-end hardware and high-end hardware, one of the key problems is you don't know whether a given phone or a target device can execute the next piece of code as fast as it gets. So what do? How do we solve it? Well, we actually take key things from your content that are declared ahead of time, things like required capabilities, whether you're using just a face tracker or a plane tracker and person segmentation. We're also going to take texture and mesh sizes into account when doing that, so we can handcraft and tailor and load all the things that we need ahead of time or progressively. On top of that, we're going to start running your content behind the scenes on the server to decide whether we need to dedicate more time to CPU or GPU, and how do we handle the parallelization of the whole system together by measuring scripting and rendering performance. All of this allows us to pick the most optimized path of execution, allows us to predict where do the resources going to go, and where do we need to go and tweak a few knobs, and which systems do we need to scale down. Next, connection class. So what do we mean by connection class? Connection class is a theoretical class that we assign to a device in its current context, in its current position. Say you're using a Wi-Fi connection or using a cellular. On top of that, we're also going to take historical and current stability and historical and current speed into account. Knowing all of that information ahead of time actually allows us and unblocks picking the best delivery approach. Say picking a faster compression rate that is faster to uncompress, or a more advanced one that is slower to uncompress if it's a high-end phone. Last but not least, reactive runtime. So what do we mean by reactive? Is it React? Really? Do we write JavaScript all the time? Well, no, not quite. What we mean by reactive is that it's more declarative than imperative, as our programming model for JavaScript. What this means is that it's fully data-driven, so we don't execute the full simulation every frame. Rather, we pick only the things that changed. We know what's going to happen next, because it's declarative as well, and we can unblock and allow the fastest, most streamlined execution path optimization out there. This is what you interface with through JavaScript and patch editor as well. On top of all of this, graphics. When it comes to rendering, we know we run multitude of hardware. Well, that means we also have different APIs that we need to support. Say, OpenGL 2 is supported properly uniformly everywhere. So we will definitely optimize for it. But then when it comes to OpenGL 3.2, which is supported by less amount of hardware, we actually going to go and dive deep and use all of those extensions, all of the new tricks and pieces that are available. Because with every one of them, we can actually squeeze in those extra 5–10% of performance on that target device. We also started looking into Metal and Vulkan. This is one of the reasons we have our own shader pipeline, one of the reasons we have our own visual shader system. We could allow interfacing directly with GLSL, which is the OpenGL shader language, but, well, we cannot actually go in and port that content directly to Metal or Vulkan because they use different shading languages. So we created our own shader pipeline and visual shader system to allow just for that. So you can create your content once, and it's going to run everywhere. Awesome. Let's talk about the face tracker, our favorite topic, right? So to trackers, we also apply selective optimization. What you see up top is actually the face tracker running on top of the same video. But if you squint really hard or stare at it for about 10 minutes, like I did before, there's actually a difference. The one on the left is running what we call a low-end face mesh, or low-end face model. We have two different models for a face tracker. One that is optimized for accuracy. Say, if you're building an effect with lipstick, you can opt in and say, hey, I want the high-end face mesh only, and we will never downscale. But by default, if you just want to apply a crown, well, it probably doesn't matter. On the high-end phones, however, we care about accuracy more than anything. There's a lot of compute power, so we can run the highest-end model out there. There's really a difference. The same applies to World Tracker as well. So we all are familiar with this picture, right? Dancing unicorns? Fantastic. Our World Tracker can actually run and guarantee about the same performance, which is 30 frames a second that you see up the top, no matter whether you start tracking or you progress through the scene, or even if you shake your phone. The way we do it is we still allow the same API. But behind the scenes, as you go and open up your camera and scan a plane in front of you, and you put your favorite 3D object, say a purple unicorn in this example, we actually going to run 3 trackers behind the scenes and dynamically switch between every one of them. The top one, the highest fidelity one, is 6 degrees of freedom tracking, also known as SLAM. This is what gives us the best quality, the best precision, and best accuracy. Turns out it's very expensive to run. And if we always run it at all times, we will sacrifice some of the performance, some of the runtime, and some of the rendering, and all of that is going to go just to tracking. So we built 2 more trackers behind the scenes. The interface is the same for all of them. You create your API, you use your API just once, the Super 3DOF and 3DOF. You can actually also see it in this video. So now, when you look at that top right part of it, you actually know what's happening. So the yellow is a Super 3DOF, which is average accuracy. The green one is 6 degrees of freedom and SLAM. And as you shake your phone, we lose tracking, so we need to regain tracking. We dedicate slightly more resources to it, but then we don't sacrifice the rendering. Dancing unicorns. Awesome. we talked about performance. Let's actually go focus on delivery, which is really how we ensure instant load time of dancing unicorns on your phones. Our asset optimization and delivery optimization starts in AR Studio. You, as a creator, create your effect in AR Studio, and you export it. Next, you upload it to AR Hub, which is our interface for uploading effects. Right after it, this is where our job begins. We're going to go and take your package, unpack it, apply mesh optimization, try to combine multiple materials together, try to combine multiple textures together. So the same content, the same experience, actually split into multiple different packages and delivered to all of those devices in a selective optimization manner. So we selectively optimize for the great experience. This also applies to delivering those assets to the device. Let's take a look at this detailed example. So what we have on the left is a cloud-based asset delivery system, which is probably Facebook infrastructure. What we have on the right is two target end phones, low end and a high end. Also, well, we have different connectivity. So Wi-Fi is going to be at the top, cellular is going to be at the bottom. When we deliver your effect to low-end phones on Wi-Fi, we're probably going to use a zip. It's pretty good. It's average complexity of uncompression. It's average size. It's actually very well done. The moment you switch to cellular, however, instead of shipping one big package, we're going to aggressively split it into multiple small ones, multiple small zip packages, and deliver incrementally across time as people go through your experience. Of course, we'll never sacrifice your content and your experience, and every single piece of content that needs to be there at the first frame rendered, well, it's there. As it gets to high-end phones, well, Wi-Fi, still, zip, we don't need to waste more CPU power. But when it comes to cellular, since this is high-end phones with way more compute power, we're going to use things like LZMA, which is far more advanced compression algorithms. It means it's slower to uncompress, but since this is a high-end phone, we actually can use that compute power. We can trade off a compute power for time, so the overall time of delivery is smaller, and overall time of uncompression is also smaller. So we can deliver the same content to you and everyone else in the world faster. As with performance, what we optimize for assets is that loading indicator, or rather, we're optimizing it away. On the client, we can also apply all these learnings and the previous learnings from Newsfeed. So some of you might be familiar with the active preload viewport. I hope you are. That Try AR Now button is important because the moment it enters a preload viewport, which is one screen away from what people can see, we'll probably already start preloading the AR content. As the call to action enters the active viewport, that means there's more likelihood chance people are going to click on that button and want instant load time. But hey, we already started preloading it ahead of time, and we cached it so people can experience it immediately. Last but not least, developing markets. Marlene talked about some of the emerging markets that we're seeing with 2D connectivity. Turns out that with those markets, there's also a lot of constraints on compute power. So say, we might not be able to run Spark AR engine there. What this means is we're going to take your effects, we're going to take the same engine and run it on the server. So what you see here in the video is Facebook Lite, which is a very small app tailored for developing markets specifically. But this is the same AR. This is the same effects, same content and experience, just delivered to people that actually don't have a phone that can run AR. Awesome. As we talked about delivery and performance, let's talk a tiny bit about how you as creators can apply these learnings into practice. There are three areas that we think you're best suited to optimize for. First one is assets. We actually don't know everything about your assets. We don't know how you're going to use them. We don't know whether we can trade off some of the accuracy, some of the quality for it. You know that best, you know your assets well, so say if you don't need a 2048 by 2048 texture, well, actually go shrink it. Your content is going to perform better. Second one is experience. As Marlene talked, our experiences go beyond camera. Our experiences go beyond capture and sharing. And hey, if you want to take the same content to new places, if you want to go and try them on actual mobile phone, we truly believe that you're best suited for it. And last, but probably most important, optimizing for a target device. And the target real hardware here is important because people are not going to experience your content in studio. People are going to experience them on mobile phones or on portal devices. And using that to your advantage is important. To help you with all of these, we built some of the tooling right straight into AR Studio. So say, you can actually preview the approximate asset size as you export your effect. You can also see all of the different packages that we're going to deliver to people. So say if it's being delivered to low-end Android or a low-end iOS. All of that information is already there. Same applies for control and compression. AR Studio gives you full control and real-time preview of those. So like in this example, we can take the same content and simply compress the texture to 1/6 of the size without losing any of the visual fidelity, without losing any of the quality. We couldn't really do it without you. You know best. It's your content, and you're in full control. And last, optimizing for target device is key. If you deliver your content, or you want your content to run on low-end phones, well, you probably want to test on those phones. If you want to deliver content to tablets, well, tablet is the great and perfect test bench for you. And I can guarantee no content that runs at full fidelity in Spark AR Studio is going to run at full content on low-end phones. Next tool that we built for you to allow this is Spark AR Player. Who knows about the existence of Spark AR Player? Yay. Great, okay. Well, some of you know, but this is a mobile app that we built for iOS and Android, and it's available there on App Store and Google Play Store. You can mirror from AR Studio right directly into this app. What this allows you to do is not only profile on device, but also it's real hardware. Well, I talked about that, how important that is. You can mirror to any phone out there. The lowest end Android, the lowest end iPhone, well, it's right there. But also instrumentation. There is a reason we built that frames per second counter right at the top. It gives you the current frames per second as well as a small historical graph. Optimizing for 30 or 60 FPS is actually quite important. That means people are going to experience your content on that hardware in a nice manner. And last, it's real-time performance. You can take this app with you anywhere in the world. You can use it to play with your experience, and I can guarantee that people will find the best places for your content, not next to your laptop with Spark AR Studio attached. Last, I wanted to give you a sneak preview. This is an area that we're exploring within Spark AR Engine and Spark AR Studio teams. We want to give you more real-time debugging information inside the player right there. So that black box actually gives you a number of objects, textures, sounds, and few other information like load time and number of draw calls. We also built real-time performance graphs with very fast and very in-depth information about every single bit and piece that happens. You can actually see every one of your pieces of studio that you see on the left right here, right inside the performance graph. Sneak peek. Last but not least, our asset limitation. Our current guideline for you is around 2 megabytes. So 2 megabytes is a compressed AR effect that we deliver to people. We picked that number for a reason. We got a good amount of criticism about it also. The reason we picked it is that people that experience AR are very fast. Number of places people take AR is a lot. And no matter whether people use it on a high-end phone or a desktop experience, no matter whether you use it on a 4G, 3G, or 2G connection, we want to optimize for your reach without changing any of the content or experience that you have. And, well, we have AR Engine to do it. Last, there's also a bunch of things happening at F8. My favorite topic is actually optimizing Spark AR effects for Instagram, which is going to be tomorrow. That session goes into vast detail about some of the tips and tricks, some of the pro tips about how to optimize your content, your rendering, for best experience inside Instagram and overall in Spark AR. Thank you, and have a wonderful F8.